Hello everyone, this is Supply and Demand Lesson 7, the multivariable demand curve. Okay, so what is a multivariable demand curve? Well, so far we've just talked about simple demand curves, that is, a demand curve that relates its selling price to its quantity demanded. So here's your familiar supply and demand graph. Now let's get rid of the supply curve. Now let's think about exactly what this demand function is. So you could say it like this: sales depend on price, right? Sales depend on price. Or you could write it this way: quantity demanded is a function of price. All right, it seems upside down a little bit because normally uh, the function is put up here, so this is x and this is f of x. But in economics, it's a piece of economic trivia really that comes to us from about 1890 by this famous classical economist. His name was Alfred Marshall, and he kind of wrote these things really in terms of mathematics. He wrote them a little bit upside down. It's not wrong to do it, but he just kind of went against a mathematics convention. But anyway, we honor Alfred Marshall by continuing his kind of odd way of doing it. So you could write it like this: quantity demanded is a function of price. Or you could write it this way: QD is a function of price. But really, quantity demanded, whatever this is, quantity demanded can be a function of many things other than price. It could be a function of price and income and the prices of related goods, and maybe even other things that are somehow related to the sales of this product. So that's what a multivariable demand curve is. It's a demand equation that relates all of these things over here to the selling price of some particular product. So we would write one kind of like this. So the notation gets a little bit different because we have to keep track of what's on the left-hand side. So now we're talking about the quantity demanded of some good. Let's call it good X. So the quantity demanded of good X is equal to 100 minus 5 times the price of good X. So this little piece right here is what you're kind of used to already. But now we've included these other terms: plus 4 times the price of some related good Y, minus 3 times the price of some other related good Z, plus 0.2 times income. So this is a simple example of a multivariable demand curve. Now, we can predict the sales of good X. To do that, we need values of these things. So we could just put in some values. I'm just going to make them up. Let's let px, py, and pz have these values. Px can be 10, so we're going to put a 10 in there. Py is 20. Pz, just making it up now, is 5. And let income be 200. So when I put those numbers in there, you can check my work. Put those numbers in for these right-hand side variables and stick it in your calculator. You should find that QDX is 155. All right, so what we have now is this equation. Oh, yeah, there's one other thing I need to bring to your attention. When you look at these signs, you see these signs here? Look at these signs on the right-hand side variables. They give us some information of how these right-hand side variables relate to good X. So for example, this one right here, it needs to be negative, because if the price of its own product, so this is the price of good X, right, and this is the sales of good X, that thing needs to be negative, otherwise the demand curve doesn't make any sense. It should be that when the thing gets more expensive, people buy less of it. So that's why that sign is negative. But this sign right here, it could be positive or negative. In this case, it's positive, which means that good Y and good X must be substitutes, because when the price of good Y goes up, because of that positive sign there, if this thing goes up, sales of good X go up. So substitutes are things that when the price of one of them goes up, the sales of the other goes up. Obviously, because if they're substitutes, this thing gets more expensive. People will stop buying whatever this good Y is and instead buy good X, since it's a substitute. In this case, this negative sign here means that good Z must be complementary to good X, because when the price of good Z goes up, sales of good X go down based on that negative sign. And finally, this sign right here on income, again, could be positive or negative. In this case, it's positive, which means that this good must be a normal good. That is, when income goes up, sales of this good go up. But it could possibly be negative there, in which case good X would have been an inferior good. If you don't remember normal and inferior goods, go back, I think, to lesson 2 and review that. Okay, so here is a multivariable demand curve. Alright, so just like there was an elasticity of the sales of good X with its own price, that'd be this thing, which we just called elasticity, but now because we have all these right hand side variables, we're going to call this one own price elasticity, because it's the elasticity of this thing with respect to its own price. And then there'll be cross price elasticities for these two things, and there'll be an income elasticity and so forth. So there is an elasticity for every right hand side variable, and that's covered in one of the elasticity lessons. Yeah, it's covered in lesson 5. Okay, so finally, multivariable demand curves can be estimated using multivariable regression. Usually in my classes, I just do it with Excel, since Excel has pre-programmed multivariable regression inside of it. We do it in Excel. So this is covered in supply and demand lesson 8. That's the next one, the last one, I think. And but it's a little bit beyond the scope of this class, and so I'm going to show it to you, but I don't think I'm ever going to ask you to actually do one in Excel. You just need to understand what's going on. Okay, that's it. Hope you found this helpful. Bye-bye.